Okay, hello everybody. Thanks for coming here today. My name is Victor. I'm a machine learning lead at a company called Cloud Office. And today I would like to talk to you a little bit more about what AI can actually do in retail. And I'm going to start with a very grand and bold statement, which is that AI is expected to triple retail profits by 2030. Now, this sounds almost ridiculous because this is equivalent to expanding your sales 3 times. But the reason why I decided to stick with this is because it's very believable, and it's actually very believable to very simple math, if you think about it. Now, this is being supported by 3 different independent studies, by McKinsey, by BCG, and by Bain. And I would like to tell you why I think this is very believable, and it's actually not very difficult to reach this number. So there's 4 silent leaks which basically draw from your profits when you're in the retail industry. These are not the only 4 ones, but there's a reason why I decided to concentrate on those, because they are basically the areas where AI can thrive. It's something that it can very easily solve. And these statistics that you see here, they are from the year 2024. So the first one is related with inventory distortion. So think about all the inventory management that you are doing. A lot of costs are being incurred from overage and out of stock costs. So this is the price of not being able to sell your product because you've basically made a miscalculation in the beginning, or because of the fact that you have a lot of demand that you cannot satisfy because you don't have enough product in inventory. Now, this accounted to $1.7 trillion in 2024. Then we have the product returns, so products that customers return after they purchase them, which accounted for $890 billion. Then we have shrinkage and theft. So imagine all these self-checkout stores and all the times that you try to, that some customers intentionally maybe don't scan every product, or maybe they make a mistake. So there's a lot that goes through there as well. It accounted for about $112 billion. And also there's a lot of wasted energy. So this is about 30% of the kilowatt per hour is being wasted. Just an unnecessary energy which goes in the wrong places. Now, as I said, these are 4 channels which AI can really thrive and help solve. But to estimate what the impact on a business is going to be from these 4, let's look at what this represents for an average business in the retail. So basically, let's suppose that you have $100 in sales, right? Retail is known traditionally to operate on very razor-thin margins, right? The average gross net profit margin was about $3 in 2024. Now, these 4 factors that I showed you, these 4 channels, attribute around $9 leaked from these 100. So this is 3 times more than what you earn on these $100. And because of these razor-thin margins, every dollar from these 9 that you can save is basically equivalent to selling $33 more in sales, right? So now let's see how exactly these are being handled. So before we do that, there's a very obvious question. And the obvious question is, why are we doing this now? So these are problems that have been existing in the retail business for decades, right? And there's a very common misconception. People think that AI is a very new technology. It's something that just emerged because now we see the fruits of it. Well, this is a myth because, of course, there's a lot of new technologies like the transformer architectures which sit behind the language models, or for instance, things like AlphaGo, which happened basically since 2018. But in reality, AI has been existing. The first time it was this was used as a word, AI, was in 1956. This is 70 years ago. So this was before the civil rights movement. This was maybe just about the time that Elvis Presley made his first record. Like, some of our grandparents were not even born yet. And just now we start to use AI a lot. And there's two reasons for that, right? First one is Moore's law. So we know that computational power is now sufficient to power this artificial intelligence, right? It tells you that approximately every 2 years, the computational power efficiency basically doubles. So that's the reason why the computational power that you have in your phones right now is more than the computers that used to send people to the moon back in 1969, right? It increases a lot. And of course, the second one is having enough data, because data is basically the bloodstream of all of these algorithms. They rely on the data to be able to make and to inform decisions. And today we produce about 2.1 quintillion bytes of data. And of course, all of this, both of these things, are democratized through cloud technologies. So they allow us to do all of this. So now that we know why this is happening now, let's look at the how. So how is exactly AI going to help the retail business? Now, this big data and the computational power don't just allow us to implement AI algorithms, they also allow us to combine them in some very innovative ways. And this combination is very essential because all of the artificial intelligence nowadays which exists is basically artificial narrow intelligence. You might have an algorithm which is like a computer vision program that is going to scan the shelves and is basically tasked with identifying if a shelf is empty, right? But then you're going to have a different algorithm which maybe would predict the demand, so it needs to know exactly how full it needs to be. And then there's a third module, some robotics, which is going to a stock runner, which it will identify that it needs to fill in more of the products inside the shelf, and it will go and do it. And all of these work independently, but they need to be combined so that this work. And this is precisely how a human brain operates. There is a reason why artificial general intelligence is not yet created, because we are general intelligence. And think about a simple task that you do in everyday life. Let's say that you have to cross, you're on a crossroad and you're driving a car, right? What happens is that you see the green light. First, you have to process all this visual information, right? It has to go through the visual cortex. Then you need to process audio information. Maybe there's an ambulance passing by. You need to check for pedestrians which are on the street. All of this is information that you need to absorb. Then you need to draw from some knowledge that you have. So you need to understand the traffic rules and understand that this is the correct time to go. And then you spring your muscles. So you basically activate a completely different system of your brain to basically press the gas pedal and to continue forward, right? And the combination of all of these things makes us do things that AI cannot do yet. Now, nowadays, this is becoming, AI can start basically combining a lot of these tasks, and one of the ways in which it does that is through agents, right? We have this agentic AI where you have multiple different narrow AIs, which can be combined together to accomplish a grander, a bigger task. And to grasp how what the potential of this is, a lot of people think of AI as some external intelligent entity which intervenes inside the business. But to be able to understand exactly what the potential of this is, you have to think of the business as this one big giant AI brain, which is the intelligent entity. And you can think of it like this. If you don't have any AI algorithms, you're still basically a human in the prenatal stage, right? You haven't been born yet, and there isn't much that you can do. Now, as soon as you get born, what happens is that you have an immediate sensory spark. So all of this petabytes of information come to you. If you think about a 4-year-old, it basically processes, it has processed 10 to the 15 bytes of information through visual information, auditory information, and all of this. And just to compare, 10 to the 15 power, if you think about the language models and all the information that they basically used to make these incredible technologies, this is 10 to the 13th. So this is 2 orders of magnitude less than what a human basically achieves. Now, even though this is not something which gets close by to a human being, it's still pretty impressive. These are numbers which I took from Walmart. So all of these data points in the retail business that you can basically absorb, they are the bloodstream of all the AI algorithms that you can use. 36 million transactions, right? These are the receipts. They can inform what products are popular and what products are not. They can inform if there is a peak in demand. They can tell you basically what is being sold, right? They can inform pricing decisions as well. Website visits. These are very important to understand your customers. What do the customers like? Where do they click? What they look at? All of this information is also important. Then you have IoT sensors, right? Which is all the machinery inside, everything that happens inside the store. You get the information from a lot of IoT sensors, right? Video information, 1 terabyte per store as well. So through video, you can basically understand all the traffic that's happening inside the store. You can understand what happens at the counters. You can basically spot empty shelves and things like that. And you have to combine all of this information so that you can start even doing something with artificial intelligence, right? So around month 6, what happens with an infant is that the visual cortex, the way that he processes visual information, develops a lot. It becomes the predominant part of the brain through which you understand information. And this is a very logical step in here as well, in a retail business. This is where we start speaking about computer vision. So computer vision is all these technologies that work with images, that work with video. Now, imagine computer vision algorithms, they scan the traffic inside the store. Based on the traffic, they know how to redeploy the employees to the counters so that queues are not formed, so that it becomes more efficient. Then they can scan the price tags of different products. They can see if there's any mismatches between the price that is being labeled and the actual price of a product. You can look at the products. You can see if there's any defects so that you can change those, which saves a lot of dissatisfied customers. There's these computer vision boxes where you put the products inside the box and they're automatically scanned, which are happening right now in a lot of places, which significantly reduce the amount of time that you need to, when you go to a store, to be able to buy the product and go out of the store. This time is really reduced by this fact. And all of this comes from visual information. This is the computer vision information. Now, around month 9, the motor cortex inside the brain is something which also develops quite a lot. So we can start, a baby starts moving in a very purposeful crawl around this time. And before that, it's mainly reflexes, right? And now this here, the muscle, the motor skills, is something which is going to complement now everything else that we have built on so far. So when a computer vision model scans that the shelf is empty, now it can send a signal to the stock runner, which can take the appropriate product and it can put it back in place, right? And I'm going to skip all the boring stuff that you probably already know here, but what's important to mention here, for instance, are the autonomous delivery technology, which is happening right now. In the form of, let's say, autonomous vehicles and in the form of drones, which can deliver packages which are lightweight. And the reason why I want to accentuate on that is that it's estimated that around, in the next 5 years, this will account to about $10 trillion from the global GDP. So, putting it into perspective, the entire GDP, all of the economic activity of the whole world is basically $100 trillion. So this is 10% of the GDP just based on automating all the logistics which happens inside all of the businesses, right? This is huge. Then, phase 4, around the age of 3, so now we are advancing a little bit more. We start recognizing patterns a lot better. We can match different shapes. We can match different colors. We don't only absorb the information, but we understand it well enough to see the patterns inside it. And one way in which this happens inside the retail business is through what we call these anomaly detection algorithms. They can sense if, let's say, demand is going to peak in a certain day, and if it's something which is out of place, so that when you see your financial statements at the end of the year, and if something is wrong, you can basically attribute it to some anomaly which happened, which is maybe not everyday business, which is very important. Then think about all the self-checkouts, all the customers that, let's say, don't scan a specific product. For computer vision, this is very, very easy to do. In fact, computer vision can do a lot more complex tasks than what you see here, basically. And I'm going to give you an example. So we work with a company called Nasikomo. They basically produce insects. They produce protein based on insects, right? And it's a very complex mechanism and process because it involves a lot of genetics. It involves a living organism, which is different than something which is more objective, so to say, something which is more material. And the computer vision algorithms that we use there, imagine a picture of an insect, of some living organism. Through the computer vision, we can see things that even the human eye cannot see. We can say how big they are. We can count them, which is in the billions. You can count billions of them. You can say how healthy they are. From a picture, you can see whether they're in good health status or not. You can estimate how much they're going to survive, right? You can estimate genetic characteristics of the animal just through a picture. So imagine a task as simple as checking a shelf and seeing if it's empty or not. This is a piece of cake for all these computer vision algorithms that help with this. Finally, at some point, around age 4, we can start anticipating. We can start predicting what's going to happen in the future. We don't just acknowledge the patterns which happen in front of us, but we can also make a prediction of what's going to happen next. We start asking questions, we become curious. Like all the kids that are, when they are born, they are infinitely curious, right? At some point for some people this goes away. For those people that don't, where it doesn't go away, a lot of them become scientists because they ask all the curious questions. And the same thing happens with this natural development here that we have in the retail. We can start asking what's going to happen in the future and we can start anticipating it, right? So this is the point where we can start predicting what's going to happen with the demand that we see. This is the point we have these graph ETA models where we talk about delivery delay prediction that combine data from sources related to traffic, sources related to weather, depot, throughputs. All of this is going to be combined so that we can anticipate if there's going to be any delivery delays on time. Churn prediction, or models like propensity to subscribe. Let's say you have an e-commerce website and you have customers that have subscriptions. You can anticipate which ones are going to subscribe. You can anticipate which ones are going to stop using your website and are going to defer to a different one. And believe it or not, this, from the $9 that we spoke about, taking the appropriate actions and being able to predict this sort of behavior is going to save $1 from that. This is an additional $33 to the 100. Right? Predictive maintenance as well, which is predicting when the machines are going to fail. Then we have phase 6. So at some point we start socializing with the world. We become a little bit more witty when we are kids. We experience the first time even some sort of, like when we speak with our parents, we understand what they expect. Sometimes we answer based on that. We have a lot of social intelligence which starts building up. And when you think about our AI and retail organism here that we're building, well, this is expressed with understanding the customers and communicating with them. This is where all the chatbots come in place. This is where all the recommendation algorithms that we have on our websites come in place. And these recommendation algorithms, you have no idea how effective they can be. Because think about the language models, something that we can all see, right? All of them are producing this very, very well thought out text. It basically shows science, a lot of scientific thinking, very deep logic and logical skills that it exhibits. And all of this was built based on the goal of predicting the next word in a sentence, right? Now, imagine if we take this marvel of a technology and we change the goal so that it doesn't just predict the next word in a sentence, but it predicts the next item which a customer is going to buy. So that's why it's so effective. I mean, think about all the times where you see some suggestions in your feed, whether you're browsing YouTube or whether you're watching Netflix, and they seem so on point that you become even a little bit scared. You start thinking of that they're probably listening to me, right? They cannot know this information. Maybe you just had a conversation about a specific topic with your friend, and then you see this popping up in your suggestions, right? And the reason why is based on your previous activity, everything that you have done, all your activity on the website, let's say everything that you have watched, they can anticipate that you would be interested in something before you even know it. That's how good recommendation algorithms have become, right? So, phase 7, this is when the imagination starts unwrapping, right? We don't just become curious, but we form certain scenarios inside our head, and then we try to basically imagine what's going to happen if we do a certain thing. Imagination is something which develops at a very early age, but it's present basically until around, I don't know, age 10 is maybe when it's most predominant, when it's the biggest, right? Then we become a little bit too reasonable. Afterwards, we start reasoning a little bit more. We start conforming to a lot of things that happen in society and school. We have to conform to a lot of different behaviors. But imagination is something which is very powerful. And the reason why I put this here, this covers basically all the AR technologies, all the augmented reality things that you can do. So imagine you're going to have these virtual changing rooms where you can go and you can check out how a shirt is going to look on you before you even try it. Or maybe there's a stock out, they don't have the specific product, but you can still check how it's going to fit you. And it's going to be very realistic. People think that it's not going to be realistic, and what they will see is not going to be the same as when they try on the shirt, but they do become very, very realistic, and you're going to see exactly how it's going to look like. Same goes with furniture. You want to buy a furniture inside your house, well, you can just look through a lens, smart glasses, a phone, and you can see a couch appearing in your living room, and you can see exactly how it's going to look like, so that you can make an informed decision. And finally, we have phase 8. Now, phase 8 is when we start thinking just like scientists do. We make thought experiments. We gather everything that we know. We learn from experience, right? There's something more than just absorbing information. There's a lot of problems that we can have that cannot just be solved based on knowledge. Suppose you want to change your price. Right? There's a lot of companies that exhibit this sort of dynamic pricing. They utilize this dynamic pricing, which based on demand, you can change the price. Or the question of when to put out a promotion, which is a similar thing, right? You manipulate the price based on what you expect so that you can maximize the profits. But how can you know what is the optimal price? You don't even have any information where you have previously changed your price to inform this decision. Well, you learn through experience. Right? You try to change it, you see what happens, you adjust your behavior. And the reason why you see Gary Kasparov here is because these types of problems are something that we solved 28 years ago. So in 97, Deep Blue is the machine which beat the world champion at chess, right? And think about all the hard problems that you have. Supply chain management. There's just so much things you have to think about, all things to take into consideration. Where, let's say, you decide your inventory policy, right? It's infinite and it sounds almost too complex to be able to handle. Well, in chess, you have more, the possibility of the number of moves that you have in a chess game is more than the number of atoms in the entire universe. And computers have been able to handle that very well. So supply chain management decisions, pricing decisions, all of these types of things, they become very easy for a system like this. So for the pricing, you can learn through experience. These are these types of algorithms which we call reinforcement learning algorithms, where you change something and you see what's going to happen. If you cannot afford this, there's something called digital twins. So digital twins are more popular in the manufacturing industry, but there's technologies which are very similar to that in the retail industry as well, where you can simulate your entire supply chain process. You make these simulations based on all the available data that you have, and then you can ask the what-if questions. You can test out different scenarios. You change something, and you can see what's going to happen. You perform these thought experiments, right? So here's a quote that I would like to end on. The real voyage of discovery consists not in seeking new landscapes, but in having new eyes. Now, a lot of people fear that all of these things that I present to you are going to lead to a lot of job losses and how AI is going to replace us in a way. And well, the thing is that spreadsheets, for instance, didn't defeat accountants, right? They made them analysts as well. And when we fear something, we basically exhibit a fight or flight mechanism, which often happens. But there is a much more sensible route to solving this problem, and this is adaptation. You have to adapt rather than fight or flight, because whether we want it or not, by 2030, AI is going to represent about 16% of the global GDP. And the economic growth rate with which it's going to contribute is more than the steam engine, more than the digital revolution in the 2000s, more than the robotics in the 90s combined. So whether we like it or not, we have to find a way in which we can adapt. And there's ways to adapt and to keep the jobs by focusing more on the things that AI cannot do and not on the ones that AI can, basically. Thank you.
Благодаря. Има два въпроса и двата са от типа Do you know? Така че много буквално приехте университетските връзки. Така, първият започваме с Do you know that behind Amazon's fully automated shops and computer vision control stays an army of humans who watch them and take actions? До сега четох в Gemini, вярно е, но ти знаеш ли това?
Мисля, че общо взето на всяка една технология, която е AI, в момента седят хора зад нея. И това трябва да бъде така. И трябва да продължава да бъде така. И ще продължава да бъде така още много десетилетия напред. Според мен, защото не сме стигнали до ситуацията, в която може да вярваме на изкуствения интелект до такава степен, че да знаем, че няма да не догледа нещо. Всъщност, една от така основните проблеми, които ще видим с изкуствения интелект, понеже хората си мислят как изкуственият интелект ще се обърне срещу нас, ще почне да прави неща, които ние не искаме да правим. Всъщност, най-голямият проблем, който ще имаме, е, че изкуственият интелект ще прави точно това, което ние му кажем да прави. Нали, ако кажеш на някой човек, че искаш да ти помогне да ти донесе кафе, това означава, че това му е единствената цел в живота и трябва да направи всичко неморално по пътя си, за да постигне тази цел. И ако ние не сме достатъчно внимателни да мониторираме тия системи, за да не излизат извън границите, които могат да излезнат, ще имат сериозни последствия от това нещо, така че знам. И това ще продължава да е така, според мен, още дълго време за напред.
Добре, и другия въпрос. Знаеш ли за продуктът Vision Checkout? Знаеш ли нещо? Виж, това не го проверих.
Ако не се лъжа, това са тези кошници, които са захранени с компютърна визия, които когато сложиш продукта вътре, автоматично сканират, правят OCR сканиране на баркода, за да може вместо да трябва едно по едно да минеш през продуктите си, да се сканират продуктите по по-лесен начин, за които казах.
Ами добре, това беше за сега.
Добре.
Благодаря ти много.